Let's look at word problems that we can use quadratic equations to help us solve. For example, the perimeter of a rectangle is 22 feet and the area is 24 square feet. Let's find the dimensions of the rectangle. So let's let L be the length of the rectangle and W be its width. We're given that the perimeter is 22 feet. And recall that the perimeter of a rectangle is 2 times L plus 2 times W. Therefore, this is equal to 22. And we're also told that the area is 24 square feet. And remember that the area of a rectangle is length times width. So this has to be equal to 24. Now we can divide both sides of this perimeter equation by 2, which gives us L plus W is equal to 11, or L is equal to 11 minus W, which we then can plug into this area equation, which would give us an equation that just involves W. Namely, 11 minus W times W is equal to 24, or 11W minus W squared is equal to 24. And bringing all the terms to one side, we get W squared minus 11W plus 24 is equal to 0. And now the left-hand side will factor. It factors into W minus 3 times W minus 8. And we have a product of factors equal to 0, which means either the first factor is 0 or the second factor is 0. If the first factor is 0, then W would be equal to 3. And if the second factor is 0, then W would be equal to 8. Now, if W is equal to 3, then we can plug this value into here, and we'll get L is equal to 11 minus 3, or 8. And if W is equal to 8, then plugging this into here, we get that L would be equal to 11 minus 8, or 3. So in either case, our rectangle is 3 feet by 8 feet, which are the dimensions that we're looking for. All right, let's look at another example. A model rocket is launched with an initial upward velocity of 30 meters per second. The rocket's height after t seconds is given by this equation here. Find all values of t for which the rocket's height is 10 meters. So we're launching this rocket from the ground, and we want to know the time at which its height is 10 meters. But then it's going to come back down, and we want to know the other time at which its height from the ground is 10 meters. And we can find these times by plugging 10 in here for h and solving for t. Namely, 10 is equal to 30t minus 5t squared, and bringing all the terms to one side gives us 5t squared minus 30t plus 10 is equal to 0. And now we can divide everything by 5 to simplify this equation, which gives us t squared minus 6t plus 2 is equal to 0. Now this does not factor, so let's use the quadratic formula to help us solve for t. We have t is equal to negative b, or negative 6, plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a, which is 1, times c, which is 2, all divided by 2 times a, or 2 times 1, which is equal to 6 plus or minus the square root of 36 minus 8, or 28, divided by 2. Now 28 is 4 times 7, so this is equal to 6 plus or minus the square root of 4 times 7 divided by 2, which is equal to 6 plus or minus 2 square root of 7 divided by 2. And dividing both terms in the numerator by 2 gives us 3 plus or minus the square root of 7. So we have t is equal to 3 minus the square root of 7, and t is equal to 3 plus the square root of 7. And if we put these values into our calculator, we get that this is approximately 0.35 seconds, and this is approximately 5.65 seconds. So the rocket's height is 10 meters at approximately t equal to 0.35 seconds on the way up. And then its height from the ground is 10 meters again at t approximately 5.65 seconds. And these would be the two values of t that we're looking for. All right, and these are a couple of examples of how quadratic equations can help us solve word problems. Thank you, and we'll see you next time.